AAA battery. You probably held one of these in your hand at some point, right? So try and remember what that felt like, or barely felt like. This battery weighs in at about 11 grams. Now, imagine that battery having to survive a Canadian winter. Metaphor's getting away from me. Point is, 11 grams is the average weight of a black-capped chickadee. A black-capped chickadee who, you guessed it, does have to survive a Canadian winter. Freezing temperatures, short days, sparse food, every bird who chooses to overwinter here is doing something remarkable. Without the cheat code of hibernation, they're forced to adapt in other ways. And that's especially impressive in tiny little AAA battery birds like the chickadee, who, despite their size, have some pretty astounding ways to make it to spring. There are biological tricks they share with other small passerines. Example, they enter a state of regulated hypothermia at night, lowering their body temperature 12 degrees Celsius to reduce nightly energy expenditure by 25%, with some studies showing up to 75%. There's also a social component to winter survival. Mated pairs of chickadees are aggressively territorial during the breeding season, defending little carve-outs of up to 12 acres. But as food gets scarce with the seasonal shift, that small area is simply not going to provide enough. So all grudges are forgiven as they organize into tight-knit flocks of 6 to 8 birds to patrol a combined area of more like 100 acres. Much better chance of finding food. Chickadees are opportunistic omnivores, as happy with carrion and insects as seeds and berries. But in winter, they need to be hoarders. In late autumn, they start to collect and store seeds obsessively. Chickadees can have hundreds or thousands of seed caches in their 100-acre range. They'll dip into a lot of these caches within a few days, but some can be left for more than 40 days before they're retrieved. That is a lot to keep in your tiny, tiny head at once. So what's a chickadee to do? Easy. You just grow a bigger brain. Starting in 1995, a series of studies started to show a pretty crazy correlation happening around the time of the year chickadees started caching food. Their hippocampi were getting noticeably bigger. The hippocampus is a brain structure shared among all vertebrates, including us. We have one in each hemisphere of our brain. So we've studied it pretty thoroughly, and we know it has to do with memory formation and retention. Not hard to connect the dots there. As black-capped chickadees are in a flurry of hiding vital food caches in thousands of discrete spots, the part of their brain responsible for memory inflates, getting up to 30% bigger. And in the spring, the hippocampi reduce back to their original size. The original 1995 study on this phenomenon hypothesized that it was giving the chickadees 3 advantages. 1, it encodes in their brains where each food cache is initially stored. 2, it lets them locate and retrieve that food cache when they need it. And 3, it expands the range that they can store food in and still confidently find it later. That's really important, not just because it gives them a wider area to search for food, but it spreads out the risk of other animals finding and stealing it. This feat of neuroplasticity, especially in adulthood, is so impressive. At the time, there was a lot of skepticism about the results of the study. But follow-ups in 2018 and 2024 have given us a much more in-depth view of how this hippocampal growth actually functions. Thanks to intervening advances in technology, the chickadees in these more recent studies can actually be fitted with adorable little 1.2-gram brain scanners. That's like 1/10 of a AAA battery. Combine those with a simulated environment, little plastic flaps standing in for convenient food cache sites, 6 cameras, and a neural network reconstructing a 3D representation of their movement, and we can get real-time data and visualization as to what's going on in their tiny but inflated hippocampi at a neuronal level. So, quick oversimplified detour into memory formation. Sensory data streams into the brain and gets encoded by clusters of neurons in the hippocampus. Repeated firings of these neurons strengthens the connections and the memory. Eventually, a delicate transfer operation occurs during sleep. The hippocampal memories are moved to the neocortex for long-term storage. But what we're concerned with is just that relationship between specific clusters of neurons and specific memories. That physical structure can be identified and its specific level of activity, neuron activation, can be measured. When they did that in these follow-up studies, they found 3 distinct phenomena or codes of neuron activity making use of that extra hippocampal real estate in the chickadees' brains. One they refer to as a place code. This is a firing of neurons that seems consistent with a general area, the memory of a place. Not specific enough necessarily to allow for the retrieval of an individual cache of food, but the sort of general memory trigger we'd probably expect to find. 2 is a seed code, related specifically to the presence of a seed, either when retrieving or caching it. And 3 is a little more interesting and subtle. The researchers refer to these as barcodes, though they caution against being too literal with that metaphor. These barcodes are much more specific, attuned to individual food caches. In fact, the activation of these barcode neurons at a food cache drops off steeply even 5 centimeters away from it. That's how accurate they are to specific sites. And they continue to respond at those sites long after a food cache is made. These barcodes are also behaviorally specific. Simply being that close to a cache site isn't enough to activate a barcode on its own. It's specifically the act of caching, retrieving, or checking a food site that activates them. Visiting isn't enough. And therein lies, as is so often the joy of science, the enduring mystery. The unprecedented view of chickadees' neural activity has given us answers and more questions. Because, think about it, that barcode activation is hyperspecific, occurring within 5 centimeters of a cache and responding to those specific behaviors of checking, caching, or retrieving food. So how does that help the chickadee? In a 100-acre territory, what good does it do to have to be less than 5 centimeters away from the food cache before anything in their brain pings them about it? That may be a question for the next study. But until then, there are theories and predictions. For example, that these barcodes may be a way of binding together memories of a place and a seed in a way that creates a kind of composite memory of a specific action of food caching at a specific site, a way of maintaining a discrete memory of that one cache among thousands. It's also possible that this could help the chickadee at decision points when it's close to a cache. No, it won't help them track down any one cache with 100 acres to search, but as they patrol that territory and naturally pass by a lot of cache locations, it could ping a more specific action to, say, check a little further up this tree instead of down. It is easy to get lost in all of these neurological details, but I would like to end zoomed way back out. However the mechanics and neurology functions, here we have an intrepid little bird who, every fall, just casually grows its brain to be able to find food in the winter.